Yo, yo, yo! This is the Unit 3 test review, Part B. Woohoo! All right, so I think we did this question in every single class, but here it is again. We're trying to find the distance from J to H. All right. So we want this distance right here, and if we want to find the distance of something, we want to use the distance formula. So we're going to start the problem with that guy right there. All right, now we got a couple ways we can do that. You could do the difference of your x's and put it into that spot, and the difference of your y's and put it into that spot. Or instead of doing that, you could just count the rise and the run from J to H. So that's what I'm gonna do. My rise, I'm going down 3, and my run is 2. So my rise is a -3, my run is 2, so I can fill in those spots with a -3 and a 2. All right, all right. Now you could have done the same thing by subtracting the x coordinates and subtracting the y coordinates. You might have gotten an answer that had a negative, like if I did 4 minus 6, I would have gotten a -2, but that doesn't really matter in the end. All right, so our distance is going to be 2 squared, which is 4. And -3 squared, so -3 times -3 is a +9. So that's a square root of 13, and according to my calculator, that's about 3.6 units. Okay, so that's the big mathy part of the question. You know, finding the distance from J to H. Oops, from J to H. All right, so once we've done that's not the answer. I got to actually read the question here. It says the banner is twice as long as the distance. So we're going to have to take that distance, and because it says twice as long, you have to multiply it by 2. So that'll be 3.6 times 2, which is 7.2. Oh, and I almost forgot that this says that each unit is 3 feet. So I also need to multiply by 3 because each box represents 3 feet. So 7.2 times 3 is 21.6. And it was units, but now it's feet. All right, so I know that my banner is going to be 21.6 feet. That's twice the distance of JH. And we're not done yet because here it says that it's going to cost $2 per foot. So if it costs $2 per foot, I'm going to multiply by that $2, my amount of feet by $2. And that's going to be 43.2, and that's dollars. So $43.20. All right, on the next question, we're going to have to find the slope to determine if the lines are parallel, perpendicular, or neither. So we got to remember that parallel lines have the same slope, while perpendicular lines have opposite reciprocal slope, which means if the first slope was a positive and it was like A over B, then the opposite reciprocal would be a negative, it'd be the opposite sign. And so if it's positive, change it to negative. If it's negative, change it to positive. But you also have to flip it for the reciprocal part. So if it was A over B, it would become B over A. If it was 3 over 5, it would become 5 over 3. That's the reciprocal. But don't forget to change the signs as well. Change the sign and flip it. So on number 9, that's what we have to do. We'll start with line A here. So I'm going to find the 2 points on A, and I'm going to count the rise and the run. I always like to work from left to right, so I'll start with this dot on the left. So the slope of line A is going up 1, 2, 3, 4. So up 4, and then right 2. So up 4 over 2. I could reduce that. All right, then we could look at line B. Line B, we'll pick the 2 points on line B, and I'll count up 1, 2, 3, 4. So up 4 and over 1, 2. And I could reduce that to be 2 over 1. And right away, I know that those lines are going to be parallel to each other. So I know that line A is parallel to line B. Cool, let's check out line C. Line C has a dot there and a dot there. So the slope of C is going to be the rise 1, 2. This one only goes up 3 and goes over 1. So up 3 and over 1. And last up, line D. So let's find the 2 good points on line D. That one. And the other good point is the one that's also has a red dot on it. So I'll find the rise over run between those 2 dots. I'm going down 1. So the slope of line D is going to go down 1 and over 1, 2, 3. All right, and hopefully you can see the connection between those 2 that I just did. That's a positive 3 over 1 and a negative 1 over 3. So they have opposite signs, and they're flipped versions of each other. They're reciprocals. So we could say that line C is perpendicular to line D. All right, so and that's how we're going to do all of these. But on the next one, you don't have the lines graphed for you. On the next one, you're going to have to use the slope formula. And the slope formula, it's on the, no, I erased it off the board. I'll rewrite it on the board, but it's y2 minus y1 over x2 minus x1. And you would get it on a reference sheet. So the first thing we need to do with part B is label it x1, y1. And then we'll label the other point x2, y2. So whenever I go to find the slope of line 1, I'm going to use this formula where I do y2 minus y1. So it's going to say 7 minus 3. And then on the bottom, it's going to say x2, negative 5, minus x1. So minus, and that x1 is a negative 9. So there's a lot of negative signs floating around down there. Now, my teacher taught me in Algebra 1, when I see those 2 negative signs right up against each other to make it into a plus sign. So it really says negative 5 plus 9. And when I do the math, that's 7 minus 3, 4 on top, and negative 5 plus 9, a positive 4 on bottom. So that's a positive 1, or positive 1 over 1 if you want it to be, because 4 divided by 4 is just 1. Now, when I find the slope of line 2, again, it's the same thing, x1, y1, x2, y2. So same formula, y2 minus y1, 2 minus 6. And then the x's, so negative 7 minus negative 11. So 2 minus 6 is a negative 4. And again, I have 2 negative signs pushed up against each other. So it's actually going to say negative 7 plus 11. So it's going to be negative 4 over negative 7 plus 11 is a positive 4. So negative 4 divided by 4 is a negative 1, or a negative 1 over 1. So take a look at those 2 slopes and look at how they compare to each other. One's positive, one's negative. And if I flipped a 1 over 1, if I flipped that, it would still be 1 over 1. So yes, they're opposites because they have different signs, and they're reciprocals because they're flipped. 1 over 1 is the same if you flip it, so they are opposite reciprocals. So I would say that line 1 and line 2, line 1 is perpendicular to line 2. Line 1 is perpendicular to line 2. Cool, and then the last one on this question, we're taking a look at those 2 equations, both in slope-intercept form, so y equals mx plus b. And we know that m represents slope, so the m part of both of those equations, the m for the first one, we'll just call it 1, is a 3. So the first m is a 3, and the slope in the m spot of the second equation is a negative 1 over 3. So if it makes you feel better, you can take that 3 and call it a 3 over 1. That's the same thing. And then hopefully you realize that's a positive 3 over 1 and a negative 1 over 3. So again, those are opposite reciprocals. So line 1 would be perpendicular to line 2 because their slopes are opposite reciprocals. Cool, cool, cool. And you actually have more practice on this because we gave that quiz B out as a practice. So you can get more practice on that if you need it. Okie dokie. Number 10, write the equation of the line that passes through the point. So the very first thing you should do is you should see that point. You should label it x1, y1. Perpendicular to the line blah, 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 blah. Now, I don't like this because I want my line to be written as y equals mx plus b. So I need the y to be by itself. So you need to get rid of the plus 2. We can undo plus 2 by doing minus 2. So now it's going to look good. Now it's going to say y equals negative 2x and a minus 2. And then we can easily say, all right, that's in y equals mx plus b form. And I can tell that the m is negative 2. But I want to be perpendicular to that. So I don't want a slope of negative 2. I want a slope that's the opposite reciprocal of negative 2. So take this negative 2, or negative 2 over 1, change the sign. So it'll be a positive, and flip it over, 1 over 2. That's what we need with the perpendicular lines, the opposite reciprocal slope. So now I have everything I need to use point slope form. Again, point slope form will be given to you on the test and on your exam. All right, so there's our point slope form. And when we do point slope form, we're going to replace y1, m, and x1 with these things. So our answer is going to look like y minus y1, there's y1 right here, equals m, there's m, our new slope is a positive 1/2, x minus x1. So now it's in point slope form. So this is a good answer, and if this is all the question asked, I would mark it correct and give you all the points. But sometimes they ask you to go a little further. They want slope-intercept form. So if I did that, I'd have to distribute. 1/2 times x is 1/2 x. 1/2 of negative 2. Half of negative 2 is negative 1. And then add the 3. Y equals 1/2 x plus 2. So in slope-intercept form, the answer would look like that. Both are correct. Both are equivalent. Both are good. Next question is almost the exact same. We have our x1, y1. But this time we're going to be parallel to this line. And again, I don't like this because it's not y equals mx plus b. So I'm going to change it. Okay, I'm going to move these x's over to be on the right side like it should be for y equals mx plus b. So it was a negative x. I'm going to add x to both sides. 2y equals, that was 1x plus 12. And then lastly, let's divide by 2. And it says y equals 1/2 x plus 6. The reason we want it in y equals mx plus b is because we want that m. There it is. M is equal to 1/2. And if I want to be parallel to that, I know that parallel means same slope. So my new slope is going to be the same, 1/2. All right, guys, so I have everything I need to use point slope form. Y minus y1 equals m, or m is 1/2, times x minus x1, and x1 here is 4. So again, this would be a correct answer if that's all they asked, but sometimes they ask you to go a little further. Y minus 0, I don't need a minus 0 there. distribute the 1/2, and half of x is 1/2 x. Half of -4 is -2. So this is a correct answer also. All right. Number 11 is a cool question. We're going to plot those points. -2, 1, -2, 1. There's A. 4, 4 for B. 4, 1, 2, 3, 4 for B. And what we're going to do is we're going to cut this thing into a 2-to-1 ratio. So remember, like we talked about in class, a 2-to-1 ratio here means I have 2 parts and then I have 1 part. So that's a total of 3 parts, 3 chunks, okay? So I'm going to be taking this segment and cutting it into 3 pieces. So let's go ahead and do that. And the way we have to do it, because the segment's diagonal, is we're going to have to count our rise. 1, 2, 3. Our rise is 3. And our run is 1, 2, 3, 4, 5, 6. So if my rise was 3, then my new rise is going to be that 3, but I'm cutting it into 3 parts. So let's take that 3 and divide it into 3 parts. Each part is going to have a rise of 3 over 3, which is 1. Let's do the same thing with the run. The run was 6. So my new run, I'm going to cut it into 3 equal parts. So my new run is going to be 6 divided by 3, which is 2. So my new rise and run is up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. So now my segment AB is in 1, 2, 3 pieces. And I want to split it up to where I have 2 pieces. All right, so here's my first 2 pieces. And then I have a 1-piece chunk. And that's split up at that point right there, which has coordinates of +2, and the y coordinate is a +3. So the coordinates of that point are 2, 3. So all we had to do was find the rise and run and then divide them by the amount of parts that we had. Okay, the rise and the run was 3 for the rise, 6 for the run. So divide each of those by 3. All right, number 12. This question looks a lot like one that we did earlier, except on this question, it's not graphed for you. We've got to graph it. Y equals 3x. So again, y equals mx plus b. Well, this doesn't have a b on the end, so we're going to start at 0. And I have a slope of 3, so I'm going to go up 3 over 1. Up 3 over 1. Up 3 over 1. So there's my line. Y equals 3x. Cool, and then I've got point Z here over at -1, comma 1, 2, 3, 4, 5, 6, 7. There's Z. Now we learned in class, so step 1, check. Slope of the given line, m equals 3, check. So in class, we learned that the shortest distance between a point here, Z, and a line is going to be the perpendicular. So whenever it says what is the slope of the segment that connects Z and the line, we're asking for the perpendicular slope, which means I need the opposite reciprocal of the original slope. Well, the original slope was 3. So that was a +3, so my new slope is going to be a negative. And since that was a 3 over 1, we're going to flip it, and it's going to be a -1 over 3. M equals -1 over 3. So let's check that path out. From Z, I'm going to go down 1 and over 1, 2, 3. And that's going to be my path. Okay, that's the distance between that point and that line. At what point do they intersect? Well, it looks like they intersect at 2, 1, 2, 3, 4, 5. They intersect at 2, 6, that point right there. And it says, what is the distance? So I'm going to use my distance formula. We can do that fast. And I know to find my distance of that green segment there, I will fill in these two spots with the rise and the run. The rise was a -1. The run was 3. So my distance is -1 squared, 1. 3 squared, 9. So square root of 10, which is like 3 point something. All right, guys, one more. Ew, gross. Now, remember, on yours, you're going to have a nice word bank to go off of, okay? But here, we don't have a word bank, so we're just going with it. All right, let's first look at all the stuff that was given to us. It's given that 1 and 2 are congruent. It's given that 1 and 2 are a linear pair, and it's given that H is perpendicular to K. So a lot of given stuff. So how do I know 1 and 2 are, okay, that's given. Linear pairs are supplementary. Angle 1 congruent to angle 2. I know that is given to me, so I'm going to write that. So how do I go from saying something's congruent to saying something is equal? Well, the definition of congruence is if something is congruent, then it's equal. So the definition of congruence. All right. And then this next one's cool because it's the same as step 2, but they switched out that angle 1 with angle 2. So if I'm switching, if I'm replacing, that would be the substitution property. Remember, you're going to have a word bank. You guys do really, really, really good at these proofs when you have a word bank. All right, it looks like they simplified by combining like terms. And then how did they go from 2 times this equals 180 to the 2 disappeared and it's now just 90? So it looks like they divided by 2 on both sides. So that would be the division property. Angle 2 is a right angle. Okay, they got there because they said it was equal to 90 degrees. So the definition of a right angle is an angle that equals 90 degrees. So that's the definition of a right angle. All right, and then it says H is perpendicular to K. Well, they gave us that at the top, so that's given. Angle 3 is a right angle. Definition of perpendicular lines. Yup, if they're perpendicular, they make right angles. And if they're right angles, they're going to equal 90 because that's the definition of a right angle. All right, all right. So if angle 2 equals 90 and angle 3 equals 90, now this could go a couple different ways. I think the answer key says substitution property. But I think our textbook might argue that it could be the transitive property. They look very similar, don't they? Our textbook's a little bit looser with the definition of transitive. All right, and if they're equal, they're congruent. That's the definition of congruence again. And we're done. Cool. So that's the whole review now. Make sure you study up. Remember, you're going to have a word bank on yours, so it's going to be a lot easier than the one I just did. All right. Have a nice day.